Modern commercial aircraft instrument panel often have installed a true airspeed indicator to supplement the information provided by the airspeed Mach indicator. True airspeed uh, is indicated airspeed corrected for variation in pressure, altitude, and temperature. TAS is always greater than indicated airspeed, except in extremely low temperature at low altitude. Pneumatic TAS indicator have uh, typical pneumatic TAS indicator have aneroid differential pressure diaphragm, bulb temperature diaphragm. Their typical pneumatic TAS indicator responds to changes in barometric pressure, impact pressure differential, free air temperature. The action of the diaphragm are mechanically resolved to so true airspeed speed in knots on the dial face of the indicator. Electric TAS SAT system is shown here, which is an electric flight instrument that provide a digital incandescent display of both true airspeed and static air temperature from analog signal received from a TAS computer or from an independent airspeed network contained within the static defect correction module. This is the vertical speed indicator principle. The pneumatic vertical speed indicator is a sensitive differential pressure instrument that measures and displays the rate at which an aircraft is ascending or descending in altitude. The VS indicator is connected to the static system and senses the rate of change in static air pressure. The rate of altitude change as shown on the indicator dial is positive, negative in a dive, positive in a climb. In level flight, the pointer remains at 0. This is the diagram of that vertical speed. The case of the instrument is airtight except for a small connection through a restricted passage to the static line. Inside the sealed case is a diaphragm with the connecting linkage and gearing to the indicator pointer. Both the diaphragm and the case receive atmospheric pressure from the static line. When the aircraft is on the ground or in level flight, the pressure inside the diaphragm and the instrument case remain the same and the pointer indicates 0 vertical speed. When the aircraft climbs, the pressure inside the diaphragm decreases, but due to the metering action of the restricted passage, the case pressure will remain higher, which causes the diaphragm to contract. The diaphragm movement actuates the mechanism causing the pointer to indicate a ratio of climb. In addition, the pressure conditions are reversed. The diaphragm pressure becomes greater than the pressure in the instrumentation case. This causes the diaphragm to expand, which drives the pointer mechanism to indicate a rate of descent. When the aircraft levels off, the pressure in the instrument case becomes equalized with the pressure in the diaphragm, causing the diaphragm to return to its neutral position and the pointer to return to 0. When the aircraft is ascending or descending at a constant rate, a definite ratio is maintained between the diaphragm pressure and the case pressure through the calibrated restricted passage. Since it requires approximately 6 to 9 seconds equalizing the two pressure, a definite lag persists before the proper vertical speed is indicated. Also, any abrupt change in the aircraft altitude may cause erroneous indication due to the sudden change of airflow over the static port.